go ahead and we'll get started here. So quickly about the midterm, I know we mentioned it last week, but I just kind of want to, throw this out here real quick. If anybody has any questions about that study guide or about the midterm, I think I told you I'd have it posted by Wednesday. I'm still kind of working on it. So I may post it a week earlier, but I'm going to give you guys until the end of next week to get it done. I think that's fair. Again, just to reiterate, when you start the midterm, you're going to have an hour to finish it. It's not going to deal with anything that we're going to be talking about today. It will have some spray rig stuff, but we're going to be doing some kind of equations, calculations, and different things like that. So this stuff is not going to be on the test. Don't stress over it. Don't think that you need to try to learn this and I'm going to test you on it. I'm not going to do that for the midterm. So the midterm is going to be the study guide. It's going to be that stuff. But once you do start it, once you feel like you're ready and you've prepared and you've studied enough for it, you will be able to take that at any point. But once you start it, you're going to have an hour to finish it. So just make sure that, you kind of block out an hour of time where you're not going to get interrupted or anything like that. I don't care what time. It could be 2 o'clock in the morning. It doesn't matter. Completely up to you. But do you guys have any questions on the study guide or the midterm, anything kind of around those lines right now?
Are we gonna go over the study guide on Wednesday? Is that what you're saying?
No. The study guide is kind of more of just like at your own kind of pace. If you do have questions, and if you don't have questions, if you haven't had a chance to really look at that yet, you are more than welcome to look at that. You can email me and I'll answer questions. I don't think it was in this class. I think somebody else in another class, they asked me some questions. It might have been this class. But just make sure you specifically address what it is. I had somebody that said, hey, I need help with this question on the study guide. And that was it. Like, I don't know what question they were asking about. So I emailed them back and try to figure that stuff out. So, but if you had a chance to look at it and you're not understanding something, it should be pretty straightforward. I mean, if you look at the labs, you look at the stuff that we've gone over, it shouldn't be that big of a deal, but that doesn't mean that you're not going to have questions. And if you do, just let me know. If you're unsure and you look at that thing and you're just not sure about something, don't take that test until you communicate with me and I answer that back on you. So there's not a specific time that you have to take that test. It is just going to be open for like a week and a half and to just take it. You won't see like your correct answers and all that kind of stuff. So that way we don't have people like sharing answers. So that stuff will be turned off. You'll just get like a score and that'll be pretty much it.
So it's going to be on everything up to last week?
Up to last week, yeah. It will not be
this
week stuff. So don't stress over, because this week is we're changing gears slightly this week. And normally I have this stuff done prior and I do test on this stuff for the midterm. But we're kind of behind a little bit, with the whole online thing and everything. We're behind a little bit. And all my classes were not to the level that we would be normally. And so normally we would be at this point, but we just didn't get to it. So it's not going to be there's not going to be any math equations or anything like that on this thing. So it should make it a little bit easier on you. If you guys have like old midterms that you're looking at, you might be stressing over those old midterms. Don't look at that. This is a different test. It's not the same stuff that we've seen. Some of the questions might be the same from previous tests, but it's not going to have any equations on it whatsoever, because I don't think we haven't done any equations at all. So it'll be like safety stuff. It'll be kind of some of the chopping. It'll be on spray rigs, like the components of the spray rigs, but it's not going to be any of the equations. So make sure you look at that spray or a chemical application PowerPoint, because there's some things on spray rigs and stuff that'll be in there. Almond harvesting and corn chopping, or the silage chopping, however you want to call that.
Okay, thank you.
Mm-hmm. Any other questions? All right, we're going to jump in. I'm going to share my screen with you. And again, at any point in this, if I'm not making sense, and I'm talking like, way over your head and you're like, I don't understand it, stop me. Don't hesitate to stop me. I want to make sure that you understand this. I want to take this time to do this. This is not something that we can just kind of do in an online video, like the interaction definitely helps out because it helps make sure we keep on the same pace. And so that's why I didn't want to do just a video of this stuff, because it just wouldn't do it justice. So a couple of things. I've got two kind of sides here. On the left-hand side right here, this is going to be our lab activity that we're going to do. And we're going to kind of work together through this thing. We're going to do, quite a bit, if not all of it, really kind of together. But there's a lot of numbers. There's a lot of data. I've got a video I'm going to show you as well that I put together. Basically what this is calibrating, or how we calibrate a spray rig. We don't just go out, mix chemicals into a spray rig and then spray it out. Some people may, but that's not really good. That's not really accurate. You don't know that you're actually putting the right amount of chemicals on a field. And it could be that maybe, you're spending more money on it. You could hit legal ramifications if you're spraying too much chemical on a field. You could get hit with fines. If you're spraying too little of a chemical, it's not going to be effective. And then you're wasting money just driving through the field. A lot of these chemicals are expensive. And so we want to make sure that we're pinpointing and we're actually applying what we need to apply on the field to be effective, but not so much that we're just going to be wasting money or throwing money away. And so that's really where this calibration comes in. Doesn't necessarily mean that you have to do it every single time you spray, but it is something that you're going to want to do on spray rigs. For the example, we looked at one of those boom sprayer. Well, we looked at 2 boom sprayers last week. We're going to be doing the calibration on the green sprayer that we looked at. And so you've kind of already seen that from last week. But we're going to kind of determine how we calculate that. And this is something that once you kind of calculate it, maybe you're doing it, once every 3 months, or once, every 6 months. And if you're not making any changes, you might be good. But, you definitely should be doing this. Come on, Lane, turn back on. You definitely should be doing this, periodically, as you are spraying, because things can change, or your chemical might change. But you might be making the same application time and time again. And you don't have to necessarily calibrate a spray rig all the time. But it's important to understand how to do it and how to go through it. On the right-hand side, there is a ton of information. And in your the module for week 8, I put this in the pages. So you have this thing directly from the pages there. But then you also have a Word document, this exact Word document that I have here. And this is going to deal with a lot of equations and different things. There's a ton of information on here. We're going to go through some of it. Some of it will kind of continue on. We're just going to hit what we really need to today, but we'll kind of be working with this stuff a little bit more. I do have a condensed version, I believe, of this thing with equations on here that I will also send to you. But for right now, I kind of wanted to start with this thing, kind of explain this, kind of go through this process. And this is going to help us answer the questions on our lab sheet that we're going to be working with today. So with this, when I do test you, or if you're taking a quiz or anything like that, I do not expect you to memorize any of these equations. You can print off this sheet and you can use it, even the little cheat sheet, the short one that has just the equations on there and not all this explanation. You can print off that little cheat sheet that I will send you. And any test, any quiz, if it's on your final, I don't care. You are going to have access to those things. It may be good for you to print it off. It's kind of up to you how you want to do it. If you want the electronic copy flopping back and forth, I kind of prefer almost a paper copy myself, but that's completely up to you and how you want to handle that. But I do not expect you to memorize these equations. There are some equations that people will just flat memorize, right? For me, I know, like Pythagorean theorem. I know a squared plus b squared equals c squared because I use it all the time. I don't have to think about it. I know how to plug those numbers in. That's just something I use. I don't do sprayer application all the time. So I have to look at these things and I have to refresh myself. And I don't expect you guys to do that same thing. Okay. What I want you to do is understand how we input numbers into these equations and what we need to do. Now, the one thing with these equations, the one issue that you guys are going to have, and I guarantee you most of you are going to have this issue, it's not understanding what needs to be plugged in where, but it's you making the correct conversions to make sure that you have the proper unit. For instance, if I have something that I'm measuring in inches and I need to have it in feet, you have to convert those numbers from inches to feet. I may give you inches and it needs to be feet. You got to know how to convert that. If it's ounces, you've got to know how to convert that to gallons. If it's, what's the other thing? I don't know. trying to think of something else. Seconds. If it's seconds and it needs to be minutes, you've got to know how to convert that. On the top here, we have kind of some, kind of helpful values that are kind of there that you can utilize. Some of you may not know that there are 43,560 square feet in an acre. Okay. Some of you may have that ingrained in your head and you could just tell me that off the top and you don't have to think about it. We may not be using the miles per hour right now, but we will be using this a little bit later. We are doing miles per hour today, but understand that if you're going 1 mile per hour, that you are going to be driving 88 feet per minute. And we can figure out miles per hour by distance and time and all that kind of stuff on this equation that's on this, left-hand or right-hand side. We're going to do a lab that deals with that. We're not going to be dealing with this stuff today, but you're going to understand how to calculate what your miles per hour is going to be. But probably the most important one today that we're going to deal with is how many ounces are in a gallon. Okay. And there are 128 ounces in 1 gallon. And that's a very important number for us to understand. Again, you're going to have this as a reference. Don't think that I'm going to expect you to memorize that, but the more you use something, the more you're going to memorize it. And for those of you that are going to be PCAs, you're probably going to, remember these equations. You're probably going to use them. I've had some students in the past that they worked for PCAs and they had a little cheat sheet card that they kept in their wallet with all the equations on there. Those things are going to be there. If you're not, going to be a PCA and you're not really working with this, I know there's some ag common here. You may not use these equations ever again, and that's fine. But I don't expect you to memorize them. Okay, that's probably the most important thing. But like I said, when we use that, a pound is 16 ounces. That's going to be if we're doing dry chemicals. I don't know that I'm going to give you any. I might give you some that are dry chemicals and stuff, but again, you're going to have access to this stuff. Most of the stuff we're going to be dealing with fluid ounces. And so understand that if we have a gallon of, material, water, or whatever it is, it equals 128 ounces. Okay. And that's going to be really critical when we get into our lab exercise later today. So conversions, I'm telling you, I'm going to try to beat it in your head. Conversions are going to be the thing that kills you on these equations. Okay. I'm going to try to teach you, I'm going to try to help you understand how these equations work and what numbers need to be plugged in. And depending on what information we get, what equation we're going to use, because there are quite a few of them that we can kind of pick from, depending on the variables that we have to input into that. But when we're spraying, there's really kind of two typical ways that we are going to, two typical like outcomes or things that we're trying to figure out. One is going to be the gallons per acre. Typically that's going to be given to you on a PCA on a requisition. You're going to have the gallons per acre that is designed to be output. How the PCAs figure that stuff out to then put that on a requisition for you, that is not what I'm teaching you in here. We're kind of more on the application side of things. So a lot of stuff that we deal with could be dealing with gallons per acre or GPA. You're going to see that acronym GPA. Understand that it's gallons per acre. Okay. And that's how many gallons per acre we're outputting, or it's how many gallons per acre that, a requisition for a spray application is going to be required to do. We're going to take those numbers, okay, and we're going to determine what size nozzles, if you remember kind of the nozzles we talked about last week, what size nozzles we need to put in or what kind of output we need to have. We kind of use those numbers in conjunction, and these equations are going to help us with that. The other real kind of big thing that we deal with is our GPM, or our gallons per minute of flow. Okay. Now gallons per minute could be a representation of just one nozzle. It could be a representation of the whole spray rig as a whole. So if we have a boom sprayer that has 19 nozzles on it, GPM can either be from one nozzle or it can be from all 19 of the nozzles. We're going to kind of show you, both of those things. No matter what though, okay, if you know your gallons per acre, your GPA, okay, there's a couple ways to determine what your GPM is going to be. And you'll notice there's two kind of equations right here. We've got the miles per hour times SW times GPA divided by, 495. And then we also have a miles per hour times W. Notice the W is different from the SW, and I'll explain what those numbers mean in just a second. And then times your GPA divided by 5,940. This one is going to be the GPM per nozzle. This one is obviously our GPM for the total boom. Okay, so if you have 19 nozzles, it'd be what your output should be at each nozzle, or as in a hole. Miles per hour obviously is the speed that the spray rig's going. The swath width, or SW, right, is how many feet or how much feet that rig is covering in one pass. Okay, so SW is swath width. That's how much you are spraying as you make one pass. You come back around, you make another pass, it's going to be a different swath width. W is the nozzle spacing. So that's from one nozzle to another one on the spray rig. Okay. So how far those nozzles are placed from one another, we're going to input those numbers there. The 495, the 5940, okay, all that matters with that is those are constants. You don't need to necessarily worry about how we get those things. I'm not even going to try to confuse you with that. Understand that those are constants. That 495 and that 5940 are constants. These two equations, we are going to be using gallons per acre. You're going to know how many miles per hour the spray rig is going to be driving. And then the one thing that you need to kind of figure out is the swath width that we're going to be putting in, or the width. So that is the thing that is going to change on this equation. If you are given the width between the nozzles, okay, you can use this equation down here. If you're given the total swath width, or the total area that rig is going to make in one pass, this is a better equation to use. Okay, it's going to have less conversions as you're going through. You can take this one, and this is going to give you how much GPM one nozzle is going to put out. And if you know you have 19 nozzles, you can take this number and multiply it by 19 to determine what your total GPM is going to be. Likewise, you can do this one backwards, where you can have your total GPM. You can divide it by how many nozzles you have on your spray rig, and it's going to tell you what GPM you should have on there. Now, real quick, before I jump too far ahead, I'm going to pull up this sheet here. Okay, let me zoom in a little bit. Now, if you remember on this sheet, right, we have the nozzles here. These nozzles are going to kind of tell us, we have the little numbers here. It tells us what our width is on this stuff. Let me let him in. It tells us what we have, like on our nozzle width, it's 110 degrees. The 0.3 on like this blue indicates that we're going to put out 0.3 GPM at 40 PSI. If you had something that was like, you're putting it out and you do these equations, what your gallons per acre needs to be applied at, and you do all the calculations, how fast you're going to go, you can determine, hey, if I have a 0.45 per nozzle output that I need, I'm probably not going to use this blue nozzle. I'm probably going to jump up to this red nozzle, and I'm probably not going to run it at 40. I'm going to want to run this thing at 50 PSI, because it's going to give me my 45, per nozzle. Now, when we do the calibration thing, these numbers on this sheet are a factory test, and they're pretty close, but there are factors that change when we're actually in a field or using a spray rig that you're not necessarily going to get what these outputs are. These outputs that you see right here is a good range, a good guide for you to kind of select the right nozzle. And then we do a calibration to see, are we getting what we should be getting? And if not, then you can adjust your PSI up and down to fine tune that. Because sometimes you might get something that says, I need a 0.33 GPM or 0.32 GPM. And that's going to be somewhere in between these two. And so we adjust our pressures up to try to calculate that, to get that output out correctly, so that way we're putting the right amount of chemicals on the field. Does that make sense? Is anybody lost right now?
No.
Okay. Don't feel like, and I may go slow with this stuff, but I typically do, because I just want to make sure that I'm not trying to rush through it, and you understand how these numbers go. So don't feel like it's a dumb question to stop me and be like, hey, I don't get it. Okay. Trust me, it's going to help you out a lot more. Again, I'm not going to go over these things. You got those things there. You can look at them. I'm not worried about how we get those constants. Just understand that it is a constant. So in this example right here, if we have this, if we are given that our GPA, or our gallons per acre that we need to apply, is 25, and our speed should be 4 miles per hour. We have a boom width of 30 feet. We have 18 nozzles, and the nozzle spacing is 20 inches. we can take these numbers and we can determine what our gallon per minute should be total, and we can figure out what it should be per nozzle. So we've got this equation that's already kind of done for you. But if we take this 4 miles per hour, right, we're just plugging in these numbers, 4 miles per hour on that equation. We're taking 30 feet, that's the boom width. This is the SW, or the swath width. And because we're picking swath width, that bottom number should be 495. Okay, that's the important thing. If you pick the wrong one and you say, oh, I've got a swath width of 30 feet, and I'm going to use the 490, and I'm going to use the 5,940, your numbers are going to be off. They're not going to be accurate. We're going to do some examples. And when we do this, you should get numbers that are fairly consistent with each other. Most of the time, these numbers aren't going to change a whole lot. Depending on the application and any of the examples I give you, they're not going to be far off. And so if I have, like, if you look kind of back at this sheet here, we've got these nozzles. And if you have an output on these nozzles, you'll notice that they're all like 0.56, right? 0.89 as we get real big. The smaller ones are like 0.19. If you end up with a number and it says, hey, your output on your nozzle should be 2.52, there's probably something wrong in your equation. Make sure you recheck those things, go through that process again, because something is wrong. The output per nozzle should fall within this range somewhere. You may get something that's a 0.35. Somebody else might get something that's a 0.36. That could be a variance of maybe not carrying numbers over, rounding numbers too soon. But that's still going to be pretty accurate. And I'm going to give you a range. When you do answer these questions, there's going to be a range that you can be up or down. Okay. You don't have to necessarily have it exactly correct, because I understand sometimes rounding can make a big difference. But that's just kind of one example. Okay. If you have something that just looks astronomically different, if you have a speed, if we're doing a speed equation and you have a speed that's on a tractor that says you need to go 50 miles per hour, tractors don't go 50 miles per hour. If that's what you got for your results, there's probably something wrong. Likewise, if we have a speed that says you're going to go 0.5 miles per hour, there's probably an issue with that. Most of the spraying applications that we do are anywhere between like 3 and 5 miles per hour. You could have something that's a little bit higher. Okay. But if you're within that range, you're pretty good. There are some applications where we spray where we go really, really slow, and we are driving at that 0.5 mile per hour, and we're putting 200 gallons per acre on a field. Typically in a citrus field, that's typically where we'll see that. I am not going to give you those equations. Okay. Your speed should be somewhere 3, 4, 5, maybe up into the high 5, 6 range. If you get your numbers, and if you do the equations wrong, trust me, your numbers are not going to be anywhere close to where they should be. And that should throw a red flag up to you. So back to the equation right here. 4 miles per hour, we times that by 30 feet. It's important to understand that this is in feet and not inches. Okay, so if we're talking about our boom width, that's the total width of all the nozzles together. That number has to be in feet. If that boom width is given to you in inches, you need to convert that to feet. Can somebody help me out? How do we convert inches into feet? Some people may not know. Some people may think this is a dumb question. But if you do know, help me out. How do we convert inches into feet?
Divide by 12?
You take your inches, right? And you divide it by 12. So if you have 12 inches, you divide it by 12, that's 1 foot, right? 24 divided by 12 is 2 feet. Obviously, you may not get a round number like that, and it may not be that easy, but yeah, you divide that number by 12. And that's going to give you that. You can work that, conversely, and you can say, oh, I've got 30 feet. How do I convert that in inches? You multiply the feet by 12, and that's going to give you how many inches are in that stuff. I told you where you're going to mess up is the conversions. Okay. And when you are given an equation, you may not look at that and you may think, oh, boom width, that's, that number is going to be in feet. Understand, you got to read what's behind that to understand, are you in the correct unit for the equation that we're dealing with? You take that 30 feet, you times it by 25 GPA. This is some algebra stuff, right? You multiply all the things on top first, and then you divide that by 495. Okay, that's incredibly important. We don't want to divide something first. Sometimes it works, sometimes it doesn't. Don't do it that way. follow the, I don't even know if they call it PEMDAS anymore, but that's what they called it, right? You got multiplication, division, right? Well, there's exponents. Anything in parentheses, you got to do first. You guys know that stuff, right? If I were to do this equation, right, and we were to map this stuff out, I'll pull up a calculator here and we'll just do it. We'll go 4 times 30 times 25. I can just put this all in the calculator at once, and I divide that by 495, and I get 6.06. Now, it's important to understand what that number is representing. This is how many gallons per minute that spray rig is going to be putting out, okay, per minute. Okay, that is the total. All 18 nozzles. That's how many gallons it's going to be putting out per minute. Okay. Now, we can take that to try to figure out how much we have per nozzle. If our goal is to figure out how much it should each nozzle be outputting, we could take that 6.6 GPM. We can divide that by the number of nozzles. And that's going to give us our 0.336 GPM per nozzle. Okay. If you don't want to do that, you could use this bottom equation. We could do the same thing. Okay. If we want to know what our GPM per nozzle is, not what our total is, we take that 4 miles per hour. Again, we are multiplying it by the spacing of the nozzles, and that spacing has to be in inches. Okay. That spacing has to be in inches if we're using this 594 equation. There should be a little times right there. I don't know why there wasn't. So let's start this over. Let's go 4 times, now we got 20 inches, okay? We times that by the 25 GPA. We're not changing anything else there. The only thing that changes is the constant at the bottom. We divide that by 5,940, and that gives us 0.3367, okay? Really like 2 or 3 decimals past, 2 or 3 points past the decimal is really what I'm looking for. If you do 3, you're going to be a little bit more accurate when you answer the questions and stuff on quizzes. And when we do our final, you will be tested on this stuff. I'm going to give you a range, and I might put that range as like a 0.32 to a 0.34 on this thing. So if you put 3 decimals, you're going to be within that thing. The one thing I will tell you when you're doing these equations, do not round as much as possible. Do not round until the very end. It may make a minor difference, but it can change things a little bit. Now, between these two equations, we get the same result. If we wanted to know what our GPM per nozzle should be, my recommendation based on the information given would be to use this equation. And the only reason I say use this equation, okay, is because on this one, we have the same stuff, and then we have another step. And you're more likely to make a mistake when you add more steps into these things. So simplify them, do as best you can. If I didn't give you the nozzle spacing, okay, that might change things a little bit, okay? If you don't have that nozzle spacing, you can't simply plug that in. Now you've got to take that 30 feet, you've got to divide it by the number of nozzles, right? You've got to convert those things into inches. You're more likely to screw up. So if you didn't get the nozzle spacing, I would say do this top equation and then just divide it by the number of nozzles, okay? Because there's not as many conversions that you have to do. Does this make sense?
Yes.
Okay. If not, speak up right now so we don't move forward. It really depends. Either equation will get you one way or the other. Now, here's my thing that I absolutely hated when I was in high school and I had a math class and a teacher was like, you got to show your work, okay? I was the kind of person that was really good at math, and I would cut corners to make things a little bit simplified. So that way I was eliminating steps, eliminating the ability to kind of do that. And teachers did not like that. They wanted me to show their work. I don't care about the work. If you know the equations, you know how to plug these numbers in, you are going to get the right answer, or you're going to get really close to the right answer, depending on where you round, okay? And that's what matters. If you screw something up and you don't know how to do this, again, I'm giving you the equation. You're going to use these things on test. I have no problem with that whatsoever, because I do not expect you to memorize these things. But I'm telling you, where you're going to screw up is converting. You're not going to pay attention. You're going to rush. You're going to do that. And if you do that, you're going to get an answer that's so far off, that's not anywhere near being accurate. And that just kind of shows that maybe you haven't done enough practice with these things, and you're not really understanding, what's going on. Okay. Most of you shouldn't have a problem. You just got to pay attention. Don't rush when we're doing these things, because that diligence on, are we measuring in feet? Are we measuring in inches? Which equation should I be using? How do you select those ones? That's the important thing. Okay. Kind of inversely affected, and this is, like most algebraic equations, they're all going to be, very similar. You can get to point A from point B if you have enough of the numbers. So in this bottom example, if we needed to know how many gallons per acre needed to be applied. So typically on a requisition, they're going to tell you how many gallons per acre needs to be applied. But if we say, okay, we want to know, how many gallons are going to be applied on this field, we can kind of work this equation backwards. Now, this equation has some similar numbers in it, but you'll notice that this top one, we have the gallons per acre. This is equal to 5,940. Again, that's that constant that's going to stay the same, times our GPM. And then underneath that is our miles per hour times our width. Now, remember the last one, that width has to do with nozzle spacing in inches. Okay, so this is very much like this equation right here. So your GPM on this stuff is going to be your GPM per nozzle. So what are you outputting on your nozzle? Okay, and then you work the numbers in, and that's going to give you your GPA. Typically, your GPA is going to be, this is not grade point average, by the way, right? It's gallons per acre. Typically, your GPA on a lot of applications, especially with a boom sprayer, you're going to be anywhere between maybe like 15, 30, maybe 35 gallons per acre. I am not going to, although some applications have this, I'm not going to give you one where it's 500 gallons per acre. I'm also not going to give you one where it's 0.5 gallons per acre. That would be way too little. You would not make an application with that. You wouldn't be actually applying chemicals, correctly if you're doing 0.5. So when you're doing this equation, if you're getting a number that is smaller than what it really should be, then kind of the equations I'm going to give you, it's not within kind of that 15, 20, 35 kind of range, there's probably something wrong. And if you screwed up the equations and you used the wrong one, depending on the numbers that you input, that number is going to be so far off that it's going to throw a red flag up, and you're going to know something is wrong. Something's not right. Rework the equation, check your stuff, make sure that you're good. I don't care for you to show your work. Okay. That's not my concern. Okay. If you're struggling and you're doing these things, I will help you. That's my job. I have no problem with that. But ultimately, if you're like, hey, I get this thing, you don't have to sit there and write your steps out. Get me the right answer. That's what I care about, right? The right answer tells me you know it or you don't. Also with this one, we have our GPA. If we have our 495 constant, this is going to be times our GPM. This is going to be the total for the boom. GPM, this is not GPM per nozzle. So you got to make sure you know which numbers you are given. So that way you can work that. It's your miles per hour times your swath width. Again, your swath width is your total width of your boom. And that is going to be measured in feet again in this one. So there's inches up here and there's feet down here. GPM is total for boom. GPM up here is individual per nozzle. Are we good with that?
So if GPM is by itself, does that mean it's per nozzle? Or is that have to do with constant?
It's not necessarily a constant. I probably should have put per nozzle on there, and I will try to make sure you understand that. But as you look at these equations, and there's some things that aren't necessarily the same that I'm going to show you too, that we're going to kind of change, because there's a lot of different equations that we can do to kind of figure these out. And the one I don't have on here is how we figure out miles per hour, but we're going to do that on our lab sheet. And I think on my cheat sheet that I'm going to give you, it has the miles per hour one in there. So this one should say GPM per nozzle on here. But if it's not listed there on these two equations, if you have the constant of 5,940, it's going to be GPM per nozzle. If you have the constant of 495, it's GPM for the total boom. So if it's not otherwise stated, use that constant number to determine which one it is.
Okay, thank you.
That's a good question, though. Thank you.
Mm-hmm.
Excuse me. All right. So we'll kind of go through this one right now, and then we're going to jump into the lab on the spray rig here after this one. So if we know that we have 11.5 ounces per 15 seconds, this is output. This is our flow that we have. We know that we have 18 nozzles. We know that our speed's going to be 5 miles per hour, and we know our boom width is 30. We can take these numbers and we can determine, using these equations up here, what our gallons per acre should be. Now, on this one, this is kind of the key, and this is what we're really going to deal with today when we get into the sprayer calibration. When we're collecting these things, we don't collect this stuff necessarily for a full minute, because that could take a long time of spraying chemicals out that we're just going to either, well, you don't really do it with chemicals. You do it with water, right? Before you mix anything up. Got to make that clear. We don't want to just spray chemicals out on the ground randomly. But we do this with water. We check our flow rate and we grab this. Now, typically what we do is a 15-second interval. So we'll take a jug. We're going to collect water underneath for 15 seconds, and then we pull it out. And then what we do is we take that flow and then we measure it. If we have a measuring cup, if it's already in a measuring cup, we just kind of set it down on a flat surface and we take a reading on that. Now, when we're dealing with GPM, what does GPM stand for?
Gallons per minute.
Gallons per minute. That last word in there is kind of the key. Remember I said conversions are going to kill you on this stuff. So if it's gallons per minute, how many minutes is this thing run for? How much did we collect in a minute? We don't really know, right? It's 15 seconds. It's not a minute. What do we need to do to this number to determine how many gallons per minute we are going to collect? This is 11.5 ounces. What do we need to do to convert this into the correct form, I guess? This may be complicated. That's okay. I want you to think.
Well, can you divide 15 seconds by 60?
You can, but you can. So what do you get if you and kind of work that backwards though? Let's go 60 seconds divided by 15, or sorry, 60 seconds in a minute, right? Divided by 15. What do you get when you do that?
4.
You get 4. That the reason we do 15 seconds quite often is because it's a nice round number. If you collected for 12 seconds, you could do the same thing. Take 60 divided by 12. You're going to get, I don't know, some random number. But the reason we collect for 15 seconds, and sometimes you can do 20 because 20 goes into 60 3 times. It's a nice round whole number. It's easy for us to recognize. It's easy for us to do these calculations. So if there are 4 15-second intervals in a 60-second time period in 1 minute, what you would need to do is multiply this 11.5 times 4.
Oh, okay.
Does that make sense? I get with you, but everybody else, does that make sense? I want to make sure I don't lose you guys on this.
Yeah, that makes sense.
So that's how many ounces when you multiply that by 4. So it's important to understand how many seconds you collected for. And you multiply 11.5 times that 4, because it's 15 seconds. 15 goes into 64 times. You multiply 11.5 times 4. We get 46. Now that is 46 what? What unit should be applied to that 46?
Ounces?
It should be ounces, right? Now that's ounces per minute. So that's 46 ounces per minute that nozzle that we collected at, that's what it should be outputting. Now when we're dealing with GPM, it's gallons per minute, not ounces per minute. So how do we take this 46 and convert that into ounces? Does anybody know how many ounces are in 1 gallon?
188.
Close,
Right?
close. 128. 128.
Oh, okay.
It's okay. I don't expect you to memorize this stuff. I do. Yeah, thank you, Jared, for the chat there. My wife, it's kind of funny. My wife, when she's like, cooking or doing something, she has like the cups and the ounces, and she always has to ask me what the pints are, or what quarts are, or how many ounces are in those things. And those are just numbers that I have. When I was a student here at Fresno State, I worked in the orchards, and so I did a lot of those things and a lot of these conversions. Like we, calibrated spray rigs, all the time to make sure that we were outputting what we needed to. And so I just have that stuff like ingrained in my head. So she always asks me those things. And so those are things that I just have memorized, yeah, so I don't expect you to. That's why I give you this things that's up at the top there. So there's 128 ounces per gallon. So how do we convert this 46 ounces into gallons?
Divide by 128.
Well, let's try that out. Take that 46. Ooh, I should make sure I'm clicked on my calculator. 46 divided by 128, and we get 0.359. That's exactly what you need to do. Okay, let me work this thing again. Let's say we have 46 ounces. Sometimes you might be like, do I divide or do I multiply? Well, let's see. If we multiplied that by 128, there's not going to be 5,888 gallons out of 46 ounces. Does that make sense? Like, that's clearly a wrong number, right? So if you do that and you're like, oh, I don't remember, do I times it? Do I multiply it? Whatever. You don't want to take 128 and divide that by 46 either. That's going to give you a wrong number. So to convert these things, you're going to take that 46. I think I have this right down here. You're going to take that 46. Oh, this is wrong. Well, this is another way to do it, but it's not wrong. You're going to take that 46, divide that 46, divide that by 128, and it's going to give you that. On the bottom here, we did this differently. And again, it's not wrong. I don't care which way you do it. On this example here, we took that 46 ounces. We're trying to figure out our total GPM. So we took that 46 ounces, we times that by your 18 nozzles that you had. And then we took that 828, we divided that by 128, and it gives us 6.47 gallons. We can round up after the second decimal. You could figure out, again, like how we did it. You can take the 46, divide that by the 128, and that's going to give you the output per nozzle. You can times that by how many nozzles you have, and you're going to get the same number. So either way, no matter how you do it, you can kind of work those ones one way or the other. There's not a right or a wrong way to do it, okay? Really depends on what your result is, what you're looking for. So now that we've done that, we can kind of take these things and we can run these equations the same way. We want to determine, hold on. I don't want to confuse you guys with these things. Maybe let's go back up here. We'll simplify these. I thought I had a more simple one. If we wanted to know what our stuff is, we could take either one of those things. We could take the 0.359, or we could take the, what was it, a 6.47. We could take either one of those numbers and we can determine our gallons per acre by simply inputting these numbers. And so if we were to do that, we were to take 495, divide that, multiply that by 6.46. Is that what I said? I'm not even thinking right. 6.47. We're going to get 3,202.65. Now, in this case, my suggestion, because I'm writing this thing down now on a piece of paper, so because I'm going to have to clear this calculator, it may be better for you to do this bottom one first and then do the top one, and I'll show you why. If we do the bottom one and we have 5 miles per hour, let's get back on my calculator here. 5 times our swath width, which is 30 feet right here. We know the 30 feet. Because we don't have our boom spacing on here, it's probably better to make sure we use this one as opposed to use this one. We do that, we hit equals. We get 150, right? 150 is an easy number. You may not even need to write that down, okay? Because you can probably remember that. But I write it down, make it easy. Now we can take that 495, right? If we don't do this one first, I can take 495 times that by my 6.47. Notice how I'm getting some decimals. That's a bigger number. I can leave that in my calculator and just divide that by the 150. I don't even need to look at my paper because it's an easy round number. And these ones typically are going to be that. So good idea to do this one first, then this one, and then input that into the calculator just like you guys see. And on this equation, we're going to get 21.35 fluid ounces. You could do, sorry, not fluid ounces, 21.351 gallons per acre is what we should be applying at the current rate that we're set up with. You could do it with this one, but what you have to do is figure out your nozzle spacing. We're not given nozzle spacing. But you could do that by taking 30 divided by 18. That's going to give you your nozzle spacings. I would not encourage you to do that because it's more steps that you're going to make that you're probably going to make a mistake on. Okay. So we want to make sure that we don't, oh, I typed in 46 there. That we don't really want to mess with that stuff. Okay. So on this one, because we're just given the boom width, I would use the one that says swath width because it's just going to be easier for you. There's going to be less steps that you're going to have to take, less things that you have to try to infer, less conversions you're going to have to do. And that's where we're going to screw up is conversions. So questions with that? Cool. All right, we are going to move on to our sprayer calibration stuff. So I'm going to just kind of swap this thing over. We may reference this other sheet over here. And we're going to kind of go through this. So on our spray rig, I kind of put these things in before I would have you grab this stuff, but we're not out there and I'm going to save some time. Know that we are using the DC T-Jets, the 11003 VS. That's the VisFlow ones. So this output on this nozzle should be 0.03 GPM at 40 PSI. But we're going to actually test this thing out because it may not be outputting that correct output. Okay. And so that's what we're doing when we test these things. That's what we're going to be doing. We have a 200-gallon tank. Our pressure should be set at 40 PSI. We should have a nozzle spacing of 128. So we're going to collect the spray ounces. We're going to do it in a 15-second interval. I'm going to show you guys this video real quick of that. If I can find it. Where did I put it? It's right here. So I'll just kind of play it. It's pretty quick, little video. I don't think, do I have my share settings on there? Share computer sound. Got a little switch. I'm just turning on the stuff. You can see the spray kind of coming out there a little bit. And it's hooked up to my truck, so that way I can have a battery power. Another example, you can see we turn that on. You can see the stuff's kind of coming out. When you're at this point, it's really a good idea to kind of see the pattern, make sure that you don't have a break anywhere. I know it's kind of hard to see in these things, but you can kind of see a little bit of a spray pattern here. You can kind of see one coming down here. If you have something where it's like dripping down, there's probably an issue with one of these. The little check valves on the top of these things that we talked about last week, there was one of them that was actually gone in this spray rig. And so water was literally just shooting up straight up into the air. And so I had to find a check valve to then put in there so that way these things would function properly. But just doing a test run is a good idea, kind of look and visual check, make sure that everything's spraying uniformly and you don't have any breaks anywhere in that spray. You can see we got this set up, right? We're right about 40. We might be maybe a little bit under there, but our little regulator right here is how we adjust those things up. And that thing's actually turned down all the way. So we can't get any more than what we have right here. But I would say that's probably fairly close to 40, close enough for. Trying to get a timer set up on this thing, but I couldn't quite get it done. And I actually ran out of fluid because I didn't put enough in there. So, but you'll see on this next spot the actual test. we're going to put these things underneath there, and it's going to be 15 seconds that we're going to collect underneath this spray right here. So we hold them underneath, we collect it for 15 seconds, then we pull them out. It's an engine driven unit, so we shut the engine down. We shut the valve off. And then here we can kind of see where we're at. On this one, I would say that we're probably at the about 10 ounces, right? We can see the ounces label right here. It's important that these things are on a level surface because if it's tilted one way or back, you're going to get an inaccurate reading. And this one's at 12 ounces right there. You can kind of see different output for these things, but that can happen depending on certain circumstances. But that's why we do these calibrations, to make sure that we are going to, get the output that we actually need, or we know, hey, I need to change the nozzle out, or we've got an issue. We've got something that's, clogged, or something that's maybe not the right nozzle because it output way too much. Here you can see on this rig, I think I talked to you guys about this last week, but this little switch right here is just connected to the battery. That would connect to the battery on the tractor or a Gator or whatever. It's a little bit difficult with the truck, but still the same thing. Just got to have some power source there for the switch to turn on, to open up these valves to let that stuff flow. So when you're going and you're spraying, you basically have that thing right next to you as you're driving, and you flip that switch on and off, and it stops the flow, or it allows the flow to happen. All right. Get out of this thing. Escape. Okay. It's not as cool. I recognize that. It is pretty cool when we do this in person, because I have everybody that, has a container, and we each have, one nozzle and stuff, and we can collect it pretty quickly. Doing this by yourself can become very tedious, and it can be very difficult. And so on your sheet, what we have is the two nozzles. I kind of bolded them right here, this one and this one, where we had our 10 ounce and our 12 ounce. And then I'm going to be honest with you, I didn't do the calibration on all these other things, but I'm not really that concerned with it. So I just made up numbers that were pretty close within there. But in all reality, you are going to have these nozzles that are going to have different outputs because of wear. As these things, get used, there is going to be wear and tear. The nozzles are going to open up. You might have more of an output than what you should, depending on your PSI. And we can account for that. We can account for that by speeding up a tractor a little bit more, increasing that. We can account for that by lowering our PSI down a little bit if we're up a little bit too high, and we can kind of fine tune these things. Or we can just know, what, I need to replace these nozzles. I need to get new nozzles because I don't have any kind of accuracy at all in these things. So a couple of things and what I need you guys to do. You guys are going to do a lot of this on your own, but I'll just give you a couple examples. We'll work down and we'll kind of do some of these equations with some fake numbers, and you guys will fill these things out once you actually get the whole numbers. But I don't want to waste your guys' time doing this. But on here, on each one of these nozzles, what you need to do, this number that we have, this 11.5 or this 12 or this 10.5, whatever one it is for each nozzle on each boom, and there's a left boom, a middle boom, and a right boom. I don't really care which ones are which. You guys don't need to worry about that. If we were in person, we would, talk about that, but you guys are you guys would collect the data and then, crunch the numbers. And that's kind of what we're working with right now, is crunching the numbers. Now, this needs to be, this is your boom one, it's ounces per minute, but what we collected was 11.5 ounces in 15 seconds, or we collected 12 ounces in 15 seconds. To convert that to the GPM, it's the same equation that we did before. We're going to take that 11.5. We're going to times that by 4. Each one of these is 15 seconds, by the way. I'm not going to, mess you up and give you a 20-second or something else. Every second is going to be the same. It's the ounces that are going to change. So you do that. We've already done this equation, right? 46, divide that by 128, and that's going to give you 0.35. You could do 36 if you wanted, 0.36. Okay. Same thing with this one. You're going to take the 12, right? You're going to times that by 4 because there's, 15 goes into 64 times. Divide that by the 128. You're going to get 0.375. On this one, I would probably just leave it at 0.375. It's not going to hurt anything, so on and so forth. You guys are going to do this for all these equations. Obviously, if it's the same number, if it's 12 ounces, you're going to do that. Depending on how accurate your ability to read these things are, it's going to change things a little bit. The one thing that you are going to do is after you fill out these things and get the GPM for each of these booms, you're going to tell me the average that each boom is going to put out. And we're going to call that the mean. And if you guys know anything about mean, median, and mode, that they're going to be a little bit different. But the mean average is literally going to be all the numbers in that boom, add them together, divide it by the number of nozzles. So for instance, what we've done so far, we have a 0.36, we plus a 0.375. Okay, if I hit equals, it's going to give me that number. Okay, 0.735. I am only putting 2 numbers in, so I'm going to divide this number by 2. And my average between those two are going to be a 0.3675. Does that make sense? You're obviously going to do that for the whole boom. You'll input those numbers down here, boom, boom, boom. And then you'll take those ones and you're just going to average those all together. So trying to see if we have a discrepancy between one boom and another. Is there one boom that's maybe spraying heavier than another boom? Because, if you have one that's spraying heavy and one that's spraying light, it can average your numbers out. And this is just kind of an indication, like, do we have something that's higher? Is there maybe something that maybe a line's pinched off and we're not getting the actual pressure delivered to our nozzle in a particular boom? That's why we kind of separated those, because there's 3 different lines that run for each boom. The one in the middle that has less nozzles, you may see a spike in those things. That's the only reason we want to separate these things out, is just to collect that data, to see some things that are happening and see maybe some inconsistencies that, that are appearing. And you may not see something. They may be pretty close to each other. But in all, when everything is kind of done, you got those numbers, just give me all the averages of all the booms, that number that you get right here. If that happens to be a 0.35, okay, I'm just going to guess at this right now because I don't know what it is actually going to be. That's the number that you're going to plug in for your equations, okay? That's going to be the one that you're going to use. You're going to average out all your nozzles and you're going to do that, okay? It may not be the actual output, okay? But the averages are going to be a little bit easier to kind of work with. If when you're taking these nozzles and you have one that is far off from another one, let's say this is supposed to be 0.36 and you've got one that's like a 0.21, it could be that you have the wrong nozzle in there. Maybe somebody swapped it out. It could be that there's some blockage in there. Maybe the filter needs to be cleaned behind that. There's something going on. We need to kind of check that out. We need to look at that. Or we might just need to replace that nozzle and repeat it. But if the numbers are within a half of an ounce, especially only after a 15-second interval, it's not that big of a deal. They're going to be pretty close to each other. You don't have to stress over that too much. Okay. Only if you have numbers that are drastically different, should that throw a red flag up to you. And none of these ones I don't think should do that. But when you run them, you'll kind of find out. Easier just to find the average there, okay, of each nozzle. When we go down here, we can take our total GPM. So we can take, if it's a 0.35, we can times that by how many nozzles. We do have 19 nozzles on this thing. So our total GPM would be, if I can click on it, would be 6.65. Again, these are not the numbers. Okay, you're going to run the numbers. I'm just running through these equations with you. Now, the one thing that's going to be different, if we have on here, we're given this recommended GPA of 25. Okay, and so what we want to figure out is, okay, we have our rec that says 25. We've got our gallons per minute that we're outputting for the whole spray rig to be 6.65. I want to know what speed I'm going to run at. Okay, To figure out your required speed, and this is probably something that you're going to use if you're an operator, this is the equation that we're going to use here. Okay, so to figure out our required speed, what you're going to do is you're going to take your total GPM, that's that 6.65. You're going to times that by the 5,940. This is, again, this one's a little bit different because it's not the inches, the swath or the width, right? It's taken essentially the swath width, but we're taking this constant of the 5,940 there. So we're going to take the 6.65. We're going to times that by the 5,940. I'm going to get 39,501. I'm going to write that number down. My GPA should be 25. My swath width on this thing, I have to figure this thing out. My swath width is 20 inches. There's 19 nozzles. So I'm going to take 20. I'm going to times that by 19. That gives me 380. This is in inches. So to convert that to feet, because that's what the swath width should be, I divide that by 12, and I get 31.67 feet. Okay, 31.67 feet. I'm going to multiply that by my gallons per acre, which is going to be 25, and I get 791.67. I can then take my 39,501 that I wrote down. I can divide that by my 791.67. And I should get a number when I hit equals. I should get a number that's probably 3, 4, 5, maybe into the 6 mile per hour range, but probably shouldn't be up that high. But that would be okay. If I got something that was like, hey, I need to go 52 miles an hour, that's a problem. We did something wrong. We're going to find out right now. Oh my gosh, I screwed something up, didn't I? Look at that. I did this earlier and I did that. Maybe.
I think you multiplied by 25 twice.
Oh, okay. That might be why. Okay. Thank you for checking me. See, I was doing that on purpose so that way we could figure that out. I'm kidding. Okay. So we need to figure out our swath width. Okay. So we have 20 inches on our swath width. We times that by 19. That gives us 380. We divide that by 12. We times that by 25. The 20 is the swath width in inches. And that's going to give us 791. I think what I need to do, I think I screwed up this equation here. We're going to keep that 791 there. On this one, we're going to get rid of this one because my numbers are off, right? So I think I might have screwed something up. In fact, we're going to go total GPM, and I'll change this thing on your sheet. It's 491, 495. We're going to try to put the 495, try to keep these things constant here and see if that maybe makes a difference on this stuff. So we're going to get rid of that 39,000 number that we had. We're going to keep that 791 for this half of the equation. And we're going to run this with 495. Okay, so we're going to take the 6.65. We're going to times that by 495. I'm going to get 32,901. Divide that by 791.67. And now I'm going to get a number that is a little bit more accurate. So on this equation, and I'll resubmit this stuff for you. Well, maybe I don't want it to screw you guys up. This equation, right, that 5,940, we should have either that, and you should be able to work this thing if you have the same equation. We're going to test this out right now if we do. We're going to change these things to the 5,940, and we're going to change it to our width in inches. We're going to run these numbers again here. But this time we're not going to take total GPM. It's going to be GPM per nozzle. Okay. Where is my verb? Okay. Anywho, so let's try this again. Let's verify some things. Let's make some things work. Our GPA should be 25. Our nozzle spacing is 20 inches. So 20 times 25. I did that wrong. 20 times 25. We should get 500. Is that right? Yeah, okay. Did it again just to make sure. And we're gonna see if this one works here. Our GPM per nozzle, what did we say, is a 0.35, right? So 0.35 times that by 5,940, we get 2,079. Divide that by the 500, we get 4.158. So it's the same number depending on what we need to do. So still kind of working the same equations there. I don't know why I had that equation messed up. And I did one earlier, but I must have, transposed a number. So I apologize, but that's a good example, right? Where we get the number and we're like, okay, that's not right. Let's look at these things. Let's redo these equations. Either one of these things are going to work for you. Okay. On this one, you might just use this bottom one right here because it's there. But questions with that? Did I screw you up enough? All right. How many gallons per acre would the output be if we were running 5 miles per hour? Okay, so we're going to kind of take this equation right here. Okay, and we could take either one of them. I might take this top one because I'm given the width in inches already. And then what I'm going to do is, instead of running it at that 4.1 miles per hour, what if we increased our speed? What would our gallons per acre be? How is this going to change that? And again, this is an example. You're going to run through these numbers and you will, do this yourself. These are not the actual numbers. But if we take this equation right there and we input 5 miles per hour times our width of 20 inches, that's our nozzle spacing, we're going to get 100. So that's a nice, easy, round number for us to remember. We're going to take that 5,940, that's that constant, times it by our 0.35. That's how much our average of our nozzles would be. Again, in this mock example, we get 2,079. We divide that by our 100 from the miles per hour times our width. And our output in GPA is going to be 20.79. So it would be 20.79 is what we'd write in there. This one's going to be 4.1. I don't remember something. Okay, so that is 20.79. That is our GPA. Okay, if we would run it at 5 miles per hour. So if you increase it, you're going to take that recommended 25 and you're going to drop it to 20.79 by increasing it 0.9 miles per hour. Now the last question that we have, this one should be pretty simple, but we'll kind of run through it. At this rate, how many acres would one tank spray if we were running these things at 40 psi? So we were getting the same results here. How many acres would this tank do? And the only thing that you really need to know is you need to know your GPA, right? And you've got that right here. Okay, so one question kind of builds off the other. So you need to know your GPA, and then you need to take that, okay, and you need to know how big of a tank do you have? How big is the tank that we are spraying? How big is that tank? $200 gallons, right? So what do? We take that 200, okay, that's our tank size, divided by our GPA. That's 20.79. And we should know that within that tank, we should do just a little over 9.5 acres, okay? When you're driving in a field, if you're spraying and you're doing this stuff, typically kind of where your acreages are at. If you're doing a block, that if it's a 10-acre block or if it's a 50-acre block. And if everything's like equal and even, it's a little bit easier to do this. And you can say if it's a 50-acre block, you should get through just about 1/5 of that block, right? If it's a 50-acre block on one tank, right? Just a little underneath that. It should take you, 5 tanks or just a little over 5 tanks to actually finish that 50-acre block. And so it's a way for us to kind of check and balance to make sure that as we're operating, are we applying the chemical that we did? When we did our calibration, that's great. Are we running at the right speed? If you're running at a speed and it says, hey, you want to run at 5, but you're only running it at 4.9 or 4.8, or you're running it at 5.2, those are going to change your numbers a little bit. Some tractors don't have the ability to fine tune and really make that, that speed exactly what you want it. Sometimes you do, and those are nice because then your numbers are going to be a little more accurate. but sometimes it's just us driving through. If you're operating this with a gator, there is no set speed. There's no hand throttle. You basically put your foot on the throttle and it goes. And you have to kind of really work with that to make sure that you are operating at a consistent speed as you're going through. Otherwise, you're going to get an inconsistent spray. There are more equations that are down here. These are the same things, and they just kind of explain this stuff right there to you. So your task is to complete all the GPMs for each of these booms, to average those things out, and then to get a total average overall, and then to answer these questions correctly with the numbers that are given to you on this sheet. And then from there, you will just submit this and you'll be good to go. What questions do you have? None?
I had one quick question about the required speed one. So
Okay.
are we multiplying by the swath width or just the width?
So on both of these equations here, let me zoom this thing in for you if I can. So just like the other equations, okay, and this one, again, on your sheet's kind of screwed up. You might want to take maybe a screenshot of this right now so you guys have this. Because if I try to update that, if somebody's already entered information, I think it's going to change things, and I don't want to do that. But you can add this equation in there. You can add both of them in. Depending on whether it's swath width or width is just dependent on the numbers that you're given. And in this equation, you're given that it's 20 inches per nozzle. So I would use this equation right here, just because it's going to simplify things a little bit more. If you're given the swath width, okay, and you have your total GPM, then you might want to use that top one. But it's just like the GPM and the GPA, you can flip flop and use either one of these things. It'll give you the same result. Okay. Just don't screw it up like I did and mix and match the 594 times your swath width, right? Because then you're going to screw it up and you're going to get the wrong answer. But again, if you get an answer at your speed that is like way off like I did, understand that you made a mistake and go back and redo it. You know what I mean? There's nothing wrong with doing that.
So the 5940 corresponds with the W only, right?
Corresponds with the W. That's correct. Yeah.
Okay, thanks.
495 corresponds with the SW.
Thank you.
Anything else? All right. I'm going to go ahead and stop.